Welcome to the WTR Small-Cap Spotlight podcast. I'm your host, Tim Gerdeman, Vice Chair and Co-founder and Chief Marketing Officer of Water Tower Research. In today's podcast episode, I'm being joined by Jeff Bonar, Chief Executive Officer of CapCO2 Solutions. The company is privately held with a patented and potentially transformational technology for low-cost, high-volume green methanol production. The process sources waste biogenic CO2 feedstock from ethanol biorefineries and harnesses abundant intermittent wind power in the U.S. Midwest. The company is now setting up its first demonstration facility in Luverne, Minnesota. Also joining is my WTR Equity Research colleague, Peter Gastreich. Good morning, Jeff and Peter. Thank you for joining today's podcast.
Good morning.
Morning, Tim.
Jeff, for those listeners who may not be familiar with CapCO2 Solutions, would you please provide our podcast audience with a high-level overview of the company and its strategy, as well as providing a quick overview of your professional background, please?
Sure. Yeah, CapCO2 captures CO2 from ethanol plants, and there's a lot of clean, pure CO2 coming out of ethanol plants going right into the atmosphere right now. So it's a big opportunity. The ethanol plants are also under pressure to do something with that CO2. So we mix that with hydrogen we make from electric power, from electrolyzers, and make green methanol. And we do it in a patented way that is significantly cheaper than traditional ways to make methanol.
Excellent. And then maybe just a quick flyby of your professional background, please.
Oh, yes, please. Yeah, sure. Yeah, so my background, I have a PhD in computer science. What I did for a good part of my career is lead large teams at places like IBM, where they had really large teams. And so as most of your listeners probably know, leading large teams is all people problems. I have plenty of technical experts to handle the technical problems, but when this team doesn't want to cooperate with that team, or marketing is arguing with the engineers, that's what I needed to handle. And the whole space of low carbon climate stuff, it's a lot about getting different stakeholders with different commitments to work together. So I've found those skills from software teams at IBM to be put to good use in the climate space.
Sounds like a great fit. So with that, Jeff, I'm going to turn the podcast over for Peter to ask a few questions.
Hey, thanks, Tim. So, Jeff, before we dig into CapCO2 Solutions technology for green methanol, can we start by framing a bigger picture question? And that is, what exactly is green methanol? What is it used for? And how is its market demand projected to change over the long term?
Yeah, methanol is a fundamental chemical building block. All kinds of different products start with methanol. So in particular, plastics, any kind of rigid plastic needs methanol to kind of make it, as one of the components. So it is worldwide, a little over 100 million metric tons currently used worldwide, and that's expected to grow 5 times over the next 20 years. And most of that growth will be in green methanol. That is methanol that does not emit new carbon when you use it. One other thing to mention is methanol has also been adopted by the shipping industry as a replacement for fossil fuels. And so there are 400 ships on the water that are at least dual fuel, meaning they'll burn methanol or fossil, and that's expected to vastly expand by 2030. A lot of ships on order under construction. So a fuel is a slightly different use of it, but it's just the market is huge and growing rapidly.
Okay, certainly a huge opportunity ahead, a big growth outlook there. So, but now for the for the technology, I understand that CapCO2's process utilizes, as you mentioned, waste CO2 and renewable power to produce a methanol. How exactly does that process work?
Yeah, so traditional methanol processes, and by the way, they've been making methanol in quantity for 100 years. It's not a brand new technology. But that traditional technology, even in its most refined forms, is still a huge, complex proposition, primarily because it requires 8 passes. You convert about 15% of the methanol in each pass, and you have to recycle materials, and that just ends up being a big, complicated chemical factory, $1 billion factory, many acres to place it. Um, our CTO has developed a way to do it in one pass, and we're using traditional high pressure, high temperature reactors that are commonly used in the oil and gas industry, and we're adapting that technology to do our one pass methanol. So the only really new, unique part is exactly what goes on inside that reactor. All the rest is pretty much standard off the shelf equipment.
Peter,
So that's,
oh, go ahead, I'm sorry.
well, I was just saying that a lot of what makes us so much less expensive and less complicated is our innovation is very focused and limited. We don't have huge new rethinking of the whole world of the technology.
Jeff, as a former chemical sell side analyst, I would be remiss if I didn't ask that one pass versus 8 passes presumably drops your cost of goods manufactured materially. Is that a correct thought process?
Oh, absolutely. Thanks for underlining that. I skipped over that part. Sure, of course. And in fact, I was just reading an article about Topso, which is one of the major players in the methanol world, conventional methanol, has sponsored a e-methanol, so low carbon methanol project, um, which will compare to our pilot site at 4 to 5 times the cost. So still small and huge additional capital cost because they're stuck with conventional methanol technology.
Excellent. Peter?
Okay, thank you. So you mentioned, we saw you at the North American SAF conference, just a few weeks ago here in the Twin Cities where I'm based. And you mentioned during your presentation that with this process, there's also a potential path to sustainable aviation fuel or SAF with this technology. Could you tell us about that, please?
Sure. Yeah, there's 3 ways we benefit SAF. And the first way is we're reducing the carbon footprint of the ethanol. So any ethanol plant that wants to get into the SAF world, they need to cut their carbon footprint. They call it CI score. They need to cut that CI score significantly, and we get them, if not all the way, most of the way there. So again, we have to, each plan is different in terms of its real actual numbers, but we give them a huge boost towards their CI reduction. And so the ethanol now qualifies as a SAF feedstock. The next thing we provide is our methanol also qualifies as a SAF feedstock. And in fact, we've been told by people who know better that mixing methanol and ethanol is one of the best ways to make SAF, that you get some benefits by combining the alcohols. And finally, many SAF processes emit CO2, which they need to capture for it to still be SAF. And you can put our methanol equipment next to SAF equipment and capture that CO2 and just make more methanol. So making that more circular. So 3 big ways we boost SAF. And again, for your investors, SAF is a big, big, expensive, complicated thing. There's lots to get right before that's really going to be cost effective. We're a very useful step on the way that can be profitable much, much faster. And that's part of the design of the business is do this green fuel stuff, but do it as a step on the way, not waiting for the final reward of SAF.
And interestingly, your pilot down in Luverne, like that facility was, part of Gevo, the SAF company previously, correct?
Yeah, Gevo was pursuing a technology which, for whatever reason, they decided not to continue to pursue. They focused on a ethanol-based process in North Dakota, and so they don't need that plant anymore. So the farmers who originally built it have bought it back from them, are in the process of finalizing that deal. Not quite done yet.
Okay, that's great. And so you mentioned we talked a little bit about ethanol producers. Clearly, there needs to be something in this for them. Could you elaborate a bit more on what the economic impact or environmental benefit could be for those plants that adopt CapCO2 Solutions system?
Absolutely. The key economic driver for ethanol plants right now is to reduce their CI score. They can sell their ethanol for more money. California right now demands low CI ethanol. Other areas as well are either demanding it or will as of next year. And so that's one piece. They just have more markets and can sell it for a higher price. If they want to sell it to SAF companies, they also need to reduce the CI score. And so our business model is we supply the equipment, we reduce their CI score for them, they qualify for certain government credits, and so they get benefit that way. They get lower CI ethanol, and we don't charge them anything. And in fact, we do a revenue share of the methanol sales.
And how transformational could this be for rural communities? For example, have you identified how many ethanol biorefineries are suitable for this type of technology?
Yeah, pretty much every ethanol biorefinery is suitable. So let's start with that. Yeah, we're going to add a certain number of jobs at every site, the people managing and taking care of our equipment. We bring new revenues to the community through the methanol sales. And we also enable, I was just talking this morning with someone who's got a plan for low carbon, biodegradable plastic, and he needs green methanol to make it. And he's based in Iowa and, has ethanol plants, several near him, and he wants to be able to get his methanol from those plants. So that's another enabler. The methanol will enable businesses that right now don't have a source, and certainly not a nearby source for their green methanol.
So you have close relationships with companies like Bosch and Nikiso. In what ways do these relationships contribute to the development and scalability of your technology?
Great. Yes. So Bosch and Nikiso have been amazing, really helpful. I mentioned earlier that we mix CO2 with hydrogen. The hydrogen comes from something called an electrolyzer. Electrolyzers convert electricity. They use it to break up water molecules so we can get pure hydrogen. And one of the largest manufacturers in the world of electrolyzers, and certainly the biggest name, is Bosch. And they are working with us closely to have their electrolyzer as part of the project. And they're excited about that. Excuse me. They're excited that the most electrolyzer projects right now are very custom and require a lot of custom engineering. The idea of being able to sell to 30, 40, 50, 100 ethanol plants, essentially the same equipment, is very exciting to them. And so that's sort of why they're interested and why they've been super supportive. Nikiso, by the way, is the largest engineering firm that works with Bosch to do that custom engineering, but they're also excited and they're also very supportive, not a household name like Bosch, but again, a real supporter and huge value add for our effort.
Okay, this all sounds great. Are there any sort of challenges or barriers that CapCO2 could face when integrating this modular technology into those existing ethanol plants, and how might these be addressed?
Yeah, the biggest challenge is getting enough electricity. The more key to our process is electricity. We don't compete. Data centers are 10x what we're asking for, but we're 10x to what the grid is used to now. So that has to be worked out. And in general, the opportunity is lots of renewable power doesn't get used because the grid can't take it. In the middle of the night, the grid doesn't need wind power. In the middle of the day, solar panels are producing so much power, it's often the case the grid doesn't need it. Water power, many hydro facilities are turned off at night because there's no one to sell the electricity to. So we offer an opportunity to use that electricity because our equipment can be turned on and off. We work perfectly. You got a wind farm with a lot of curtailed electricity at night. Great, we'll just run our equipment at night. So that's there's obviously lots of details and trade-offs there, but that is a big opportunity and something we're in conversation with renewable power providers about how to best exploit that capability.
I as mentioned, I live in the Twin Cities in Minnesota and have family in Kansas City and also in Omaha. My daughter's down in college down there, and one of the biggest changes that I noticed living overseas, I left for about 20 years to work overseas in Asia and Hong Kong, and returning here. The biggest change was really just all those wind turbines, southern Minnesota, all over Iowa, and it just thousands of them. And that was the biggest change, I would say. It's just amazing how much is out there. So there's a lot of intermittent power there already, right? Available. Exactly.
And again, it's cheap, it's renewable. So that's our opportunity. And that's just going to keep growing as the grid gets smarter and better able to incorporate all that. There'll be more and more renewable power out there.
Okay, got it. So how about your financing and capital strategy? Will you look to operate projects, or will you be growing with licensing strategy? How would you expect to scale up?
Our plans are to operate the equipment and do a revenue share with the ethanol plant providing the CO2. And that allows us to cut large deals. Maersk is the world's largest shipping company. They're a leader in adopting green methanol. And, they said, well, when you have a couple of ethanol plants online, give us a call because we want to buy all that methanol. And so the plan is to be able to aggregate plants and be able to manage the methanol so we can sign long-term large contracts like that. We've also been told by some ethanol plants that they want a bigger piece of the action. They're willing to invest in the plant. So there'll be hybrid deals as well. But ultimately, we want to control the flow of the green methanol so we can sign long-term offtake contracts with really big off-takers.
Now, looking ahead from here, what are the key milestones for you, say, over the next 1 or 2 years?
Sure. Our pilot plant in Laverne, we expect it to be operating early in 2027, so first month or two of 2027. We're already talking to people about the first full-scale module, so a full-size module as a pilot for what will be manufactured, where we're going to place that module. It might be at Laverne, it might be other places as well. And then we start manufacturing those modules and placing them at ethanol plants. We really want to get away from the building a big complex chemical factory at each location, and rather you deliver a few modules, hook it up, and a few weeks later you have a plant running. That's the business model.
Okay, so we've covered a lot here. So thank you so much, Jeff, for taking the time to join us today and sharing your insights. This is a great story, and I think one that will be very new to our listeners, as it was to me. So, as renewable fuels analyst and as a Minnesotan, I'll be following your progress in Luverne very closely. Anyway, congratulations on your progress to date. But before I pass the podcast back over to Tim, I just want to give you a chance to provide any concluding remarks.
Well, great. Well, thank you for the opportunity. I'll tell you, it's been a really exciting for me to get to know the ethanol community. They just produce miracles. It's 100 million gallons a year of something where we've harnessed a microorganism to do something useful for us. And I don't know any other thing that works at that scale. And so they're really smart. They got some great technology there for how to do that. And then we're adding a lot of value to it. So it's just, the whole thing has been an exciting adventure. And I really appreciate the opportunity to share it with your people who listen to and watch this podcast.
Hey, thanks, Jeff. Over to you, Tim.
Great. Thank you for joining us today. Jeff Bonar, CEO of privately held CapCO2 Solutions. My equity research colleague, Peter Gastreich, for also joining us. Lastly, a special thanks to the producer and editor of the podcast, Krista Fitzpatrick. Thank you for listening, and don't forget to subscribe, as well as visiting www.watertowerresearch.com to stay up to speed on the company's small cap written research reports, podcast, industry-specific symposiums, fireside chats, and conference schedules. We'll see you next time for another edition of the WTR Small Cap Spotlight podcast.